You're welcome to my channel, and in this video we are going to look at the measures of skewiness. In the previous videos we managed to look at the measures of central tendency, measures of dispersion. So let's look at the measures of skewiness. Skewiness, it looks at the symmetry or the data distribution or the data concentration. That is skewiness. It's mainly about how data is distributed, and we can have normal distribution of data. We can have positively skewed or tail to the right, which is positive distribution of data. Then negatively skewed or tail to the left, which is also known as negative distribution of data. So skewiness can be in three forms. There is normal, positive, and then negative. So let's start with the normal distribution of data. Normal distribution, it is where data is concentrated in the center. Where data is concentrated in the center is what we call the normal distribution. And for normal distribution, in case you're given a data set, if you calculate for mean, it means that it is equal to median and equal to mode. And that becomes the normal distribution of data. Data is concentrated at the center, and the graphical presentation of normal distribution is this one, density, and then the score in the middle here, like that. This line has to be dotted. In the middle here, mean is equal to median and it is equal to mode. You get them when they're all equal, then you just know that it is a normal distribution of data, that it's rare to get. Then positively skewed, it is a situation where mean is greater than median. So if they give you a data set, you calculate for mean when it is greater than the median, and that is a positively skewed data distribution. It can be like this. Mean is greater, it is this side, and median is here, it is less than mean on the x-axis. So mean is greater than median and mode. Then negatively skewed, it is a situation where mean is less than the median. So if they give you a data set, you calculate the mean when it is less than the median. And the example is this. The graphical representation, mean is less than the median on the x-axis. This comes before this, meaning that this is less. So mean is less than the median, and that is a negative distribution of data. So it is all about the skewiness or data distribution. Let's look at the calculation for skewiness. How do we calculate for skewiness or data distribution? The formula is skewiness is equal to 3 into brackets mean minus median out of standard deviation. And skewiness ranges from positive 3 to negative 3. So it is the formula. Negative means that the data is skewed to the left. And positive, it means that the data is skewed to the right. From the previous example, let's get it from the previous example and we calculate. This is the formula, and from our previous example we had the mean, and our mean was 32.3. So we put it here, we substitute it in here, 32.3, and then the median, our median was 32.4. So we substitute it in here, 32.4. So, and our standard deviation, the standard deviation from the previous example, it was 10.6. So we put it here, 10.6 is the standard deviation. After that we calculate 32.3 minus 32.4. So 32.3 minus 32.4, negative 0.1. So it's what we put here. Then after we multiply by 3 times 3, it is this. Then we divide by 10.6. Divide by 10.6, which is negative 0.028, which is approximately negative 0.03. Yeah, and it is negative, meaning that it is skewy to the left. And we said for negative skewiness, it is when the mean is less than the median, and according to this, our mean is less than the median, so we had to get a negative data distribution. Yeah, and that is an example about skewiness. Thanks for watching. Yeah, don't forget to subscribe, like, comment, share with your friends, and that has been all about the measures of skewiness. Let's catch up in my next video.